For lesson 2, part 2, we are going to continue using our calculators and the sine, cosine, and tangent buttons and ratios in our calculators to find angle measures this time. Last time we found the lengths of sides in a triangle. Now we're going to find the measures of angles in right triangles. Or the measures of angles. Did I say angles of measures? I said that funny. Anyway, SOHCAHTOA, remember we have sine, cosine, tangent, and we need to remember that the sine is the opposite leg from the angle divided by the length of the hypotenuse. The cosine is the adjacent leg's length divided by the length of the hypotenuse, and the tangent of an angle is found by taking the opposite leg's length divided by the adjacent leg's length. And so keeping these ratios straight so that we can write these equations will be critical today. And so again, in order to do that, I know that these questions are repeats from our notes, but we want to ask ourselves, do we have the leg opposite the given angle? Do we have the leg adjacent to the given angle? Do we have the length of the hypotenuse? If we know these things or know variables that represent them, then that means we have it. For the work that we're going to do immediately, the variable is the angle measure. All right, we're going to have numbers for at least 2 of the sides, and our job then is to decide, are we going to use sine, cosine, or tangent to find the measure of the angle in question. And so going back to the work that we did last time, we wrote the sine, cosine, and tangent ratios for angle t, and we found that the sine of angle t was equal to opposite over hypotenuse. We learned that the sine for angle u was found by taking, again, opposite, which is 21, over 29. We did the same thing for cosine. The cosine of angle t is equal to adjacent over hypotenuse, 21 over 29. The cosine for angle u was equal to 20 over 29, the adjacent over the hypotenuse. And then the tangent, I'm going to put this over here just for space's sake. The tangent for angle u, let's start with t, is again opposite over adjacent, 20 over 21. The tangent for u is opposite over adjacent, 21 over 20. So we had those from our notes last time. Now what we're going to do is a little bit different. We're going to think about how do we find the measures of the angles t and u. And what we're going to have to think about a little bit is that just like all other operations that we do in our arithmetic, we have inverses for sines, cosines, and tangents. All right, we can do the inverse sine of a ratio to find the measure of the angle that was that had its sine, cosine, or tangent taken. All right, and so with that, just like we have inverses for addition, we get subtraction, or vice versa. The inverse of subtraction is addition. The inverse of division is multiplication, and vice versa. The inverse of squaring is square rooting, and vice versa. Cubing is cube rooting, etc., etc., etc. We have all these inverse operations that we know from all of the arithmetic operations that we've learned over the years. So we also have inverses for sine, for cosine, and for tangent. And you're going to see this little -1 exponent above the sine key, above the cosine key, and above the tangent key. It's a sine with this -1 exponent, cosine -1 exponent, and tangent -1 exponent. What that means is the inverse of sine, or the inverse cosine, or the inverse tangent. And so what we're going to be doing with that is we're going to use the sine ratio to determine the measure of angle t and the measure of angle u. So essentially, when we perform the same operation on both sides of the equal sign, that is designed to keep things equal to each other. So if I take the inverse sine of the sine of t, and I also do the inverse sine of 20 over 29, then that will give me what t equals, right? The measure of angle t is going to equal the inverse sine of 20 over 29, all right? 20 over 29. And likewise, the measure for angle u is going to be found by taking the inverse sine of 21 over 29. All right? So we are going to use these inverse operators in our calculators to find the approximated measure of these angles. So again, we want to make sure that our calculator is in degrees mode, which it is. It says DEG right there above my thumb. We should have the sine, the inverse sine of 20 divided by 29. All right, make sure that you're using the division sign and not the fraction button. Whoops, wrong button there. Come on, dog. All right, and then when I press the magical button, it tells me 43.6 degrees. 43.6. So the measure of angle T is 43.6. When I do the same thing for angle U, and I do the inverse sine of 21 over 29, second sine, to get that inverse sine, 21 29ths, it will find for us the measure of angle U, 46.4 degrees. 46.4 degrees. The measure of angle U is 46.4. Oops, and I should actually write those as approximations. Let's do a better job of that. This is actually equal to this amount, but it's approximately equal to that decimal amount. Now, the measure of angle T doesn't change. So I know the answer to this question is going to be 43.6. I know the answer to this is going to be 46.4. The answer here is going to be 43.6. The answer here is going to be 46.4. But what we're going to do is we're going to find that using cosine inverse, using tangent inverse. And so what we want to make sure that we understand is that if I take the inverse cosine of both sides of the equation, then this will stay equal to each other. All right? So I can find the measure of angle T by taking the inverse cosine of 21 over 29. So that means that the measure of angle T is, and again I'm going to approximate, and I'm pretty sure it's going to equal 43.6, but let's confirm that. When I take the inverse cosine of 21, whoops, where is it? 21 divided by 29, it's going to give me 43.6. So we were right. We have the same answer as before. The answer didn't change because I'm using a different ratio. All right, just because I'm using sine versus cosine, it's not going to change my answer. All right, but it does depend on whether or not I have those set up correctly. If I do the inverse cosine of the wrong fraction, then yeah, it's going to give me a different answer. So we want to make sure that we do a good job with that. When I do the inverse cosine for U, all right, I'm actually going to have you do this, and you confirm that that works out. And then let's look at tangent. The inverse tangent, I'm going to do U. I'm going to do this one here. I'm going to do the tangent inverse of the tangent of U is equal to the inverse tangent of 21 over 20. So I'm going to find the measure for angle U is going to be approximately equal to, and then the inverse tangent of 21 divided by 20. I should end up with the same answer, 46.3 degrees, which is what, I'm sorry, 46.397. So we are going to run that up to 46.4. So this is, again, 46.4. And these are degrees. I don't have to put the degree symbol there because you know that that's the only unit that we are using for angle measures. There is another system for measuring angles, and you'll worry about that in pre-calculus. But for right now, let's make sure that we are just working in degrees mode, and we'll answer with degrees. I do not have to put the degree symbol there. All right, I do not have to put the degree symbol there. If you want to, that's fine, but it is not requisite. All right. So hopefully that gives you enough information to make sure that you can find the measures of angles, whether you're using sine or cosine or tangent, to create equations and then solve equations using the inverse function. Please let me know if you have any questions.